question 13. So let's have a little look, see what we know. So we know that A1 is equal to 2. So let's first of all let's start off and write down what A2 is. So no, that's so A2 must be, so just stick 2 in here. So 2 plus 2, so that's 4k over 2. So that's 2k. Now let's do A3. Okay, just do that in exactly the same way. So if I put 2k into here, so then we get k, and then we get 2k plus 2 over 2k. And that gives me k add 1. Now, it says it's a periodic sequence. So what that means is that A1, A2, A3, it means that it's going to come back to A4. Right? A4 will be the same as A1. Now, if I can write A4 in the same kind of way, let's see what happens. So k times, so I've got, so A3 was k plus 1, so I've got k plus 1, whoops, forgot to add the 2, and all of that is over k add 1. If we tidy this up, I might have done a mistake, so that's equal to, what have we got? We've got k times k plus 3 over k plus 1. Now, what do we know that this is equal to? Well, we know it's equal to 2 because it's equal to A1. So I can write that's equal to 2. Multiply both sides by k plus 1. So 2 k plus 1 equals, there we go. And if you multiply these guys out, we're going to end up getting this over here. Okay, so you get 2k plus 2, k squared plus 3k, take away 2k, take away the 2, and we've got k squared plus k take away 2. Alright? Right, okay, so there's part A. Now part B. Best way to think about part B is, I have to be honest, I was looking at this and I was thinking, well, what is the problem? Because if you solve this, right, our solutions are, we could have k could equal 1, and it can equal minus 2, okay? Just solving a basic quadratic, right? So there's like the two possible values of k, but look at what happens if you put k into what we've got just here. So A1 equals 2, doesn't it? Well, let's look at A2. If I put that into there, all right, then if k was 1, well, 2, that's going to be, it's going to be 2 again, isn't it? And then it's going to carry on in the same way. All right. So A3 is k plus 1, so that's 2. All right. So it doesn't work. Right? It does not work. Right? It hasn't got a order of 3. Okay. So let's look at C. All right. So initially C, you might think, ugh, right, I've got this over here to do. So what does this thing actually mean? Well, what does it mean? It means A1 add A2 add A3. Don't worry, I'm not going to go all the way up there. Okay? Add, and then imagine that we had A80. Okay? We want to work out what this lot actually is. Well, let's work out what the value of the first few are. All right? So we know what that one is. And now remember we've got k. K actually must be minus 2. All right? So we know that A2 is 2 times k. So A2 must be minus 4. And we know that A3 is k plus 1. So therefore that must be minus 1 there. Now remember, it's periodic. So we've got this bit is going to be the same as A4 plus A5 plus A6. So what I actually need to do is I need to work out how many lots of these 3 we're going to have going up into 80. So like the important value before is A 78. Right, now A78 is, if you do 80 divided by 3, you get 26 point something. So that means there's 26 lots of these 3s. So we can have 26 lots of A1 plus A2 plus A3. A78 being like the very last one. So then you've got plus A79 plus A80. Remember, it's periodic, so that's effectively A1 plus A2. So if we just pop those numbers inside, so what do we know? We know that, remember, that's 2 minus 4 minus 1. So that's going to give us minus 3. So we've got 26 times our minus 3. And then we're going to add 2, and then we're going to take away 4. 26 times minus 3, that's minus 78. And take away another 2, and then we end up with minus 80.